Today's topic is about the speed of longitudinal waves. In the previous class we studied about the speed of transverse wave, where we got formula V is equal to root over T by mu in a stretched string. So we can use that formula only for stretched string. For other media, for other waves, speed changes. Here a speaker is producing sound wave. Best example for longitudinal wave is sound wave. So he is producing sound and the listener is listening this. So here the air between the source and the listener will execute simple harmonic motion in the direction of propagation of sound only. Here how the sound is traveling from left to right, how the particles are oscillating here. These particles are oscillating like this, students, in the direction of the propagation of wave only. That's what is called a longitudinal wave, because oscillations of the particles are along the propagation of sound wave. That's why these are called longitudinal waves. So here these particles are moving away. Here these particles are moving away. So these particles are compressing the middle particles. Understood? So due to this, here compressions are produced. What is the compression? If you see the diagram clearly, you will come to know what is the compression. Compression is a region in a longitudinal wave where particles of the medium are compressed. Compression, compressed. So particles of the medium comes closer to each other. Comes closer. What is rarefaction? Particles of the medium moves away from each other. Here comes closer, here moves away from each other. This is a longitudinal wave. Here, when the particles comes closer to each other, whether pressure increases or decreases, they are under pressure. So here, in a compression, pressure is more. Pressure is more. While in rarefaction, pressure is less. Here pressure is more, pressure is less. Students, P is equal to nRT, because I am talking about the air particles here. Air is a gas only, and air consists mostly oxygen and nitrogen. So air mostly consists of O2 and N2. That's why air is treated as diatomic gas. Why it is treated as diatomic gas? Even though air consists of large number of gases, why it is treated as diatomic gas here? Because around 24.6% of oxygen, 74.9% of nitrogen, and remaining 0.5% of all other gases. That's why air is considered as diatomic gas. So what is gamma for diatomic gas? 7/5, which is equal to 1.4. So whenever a problem is given based on this concept, consider air as a diatomic gas and take gamma as 7/5, 1.4. It has no unit because Cp by Cv. Now PV is equal to mass by gram molecular weight, RT for air. So pressure is equal to mass by volume, RT by M. So pressure is equal to, what is mass by volume? Density, RT by M. So P by rho is equal to RT by M. P by rho is equal to RT by M. So in this equation, students, if R is constant or not, universal gas constant, molecular weight of air, average molecular weight of oxygen, nitrogen, oxygen, then temperature of air is constant, then can I say P directly proportional to rho? If these are constants, P directly proportional to rho. If pressure increases in compression, can I say density also increases? Density also more in So wherever pressure is more, density is more if temperature is constant, because these two are already constant. Rm never changes. Rm always constant, but T changes. Temperature may change, but if temperature is also constant, can I say yet constant temperature P directly proportional to rho? P. In a combustion, pressure is more. In a combustion, density is more. In a rarefaction, pressure is less. In a rarefaction, density also less. Clear? Now, here, in a longitudinal wave, the speed of a longitudinal wave, while finding the equation to find out the speed of this sound wave traveling through the air, they found that the medium through which the sound is traveling or longitudinal wave is traveling, medium should have elasticity. Why? Why medium should have elasticity? To propagate or to send longitudinal waves. Why it should have elasticity? Anybody? Why it should have elasticity? See here, students, just now explain this one. Here molecules of the air move away. Then what happens? They are moving away. Due to elastic nature, they comes to their original position. Then these molecules will push. Here compression will form. Here rarefaction will form. Understood? Let us say I am the one of the molecule. Somebody pushed me on both sides. So I am in compression. But these molecules which are pushing me have elasticity. Means they came here and they will try to get to their original position. So then I have to expand. Because pressure is reduced, I have to expand. Once again compressed, expanded, expanded. So compressions and rarefactions will be formed at the same point. Here I am seeing rarefaction now. After a fraction of a second, I can see compression here. After a fraction of a second, I can see rarefaction here. So compressions and rarefactions will be formed continuously due to elastic nature of the air. Clear, students? Elastic nature of the air. So medium should have elasticity, and it should have density. But air, is it solid, liquid or gas? Gas. Air is a gas. So for gas, we don't have Young's modulus. What we have? Bulk modulus. For liquids and gases, fluids will have bulk modulus. They can be compressed easily. So for gases, this elastic nature is due to bulk modulus. What is this? Students, what is bulk modulus? Change in pressure by change in volume by virgin volume negative. Force by area is change in pressure. Change in volume, virgin volume is bulk modulus. So this is a B, bulk modulus. What is this? Bulk modulus. Then, if you see the ratio between PB and rho, because what are the essential qualities for a medium to propagate a longitudinal wave? Essential, compulsory properties. Two properties. One is elasticity. Second one, density. So here, if you take this B by rho, that is bulk modulus by density. Students, bulk modulus is also equal to pressure. Do you know this one? Have we got pressure? We will see PV is equal to nRT for air. N constant, R constant, at constant temperature, P delta V plus V delta P is equal to 0, because derivative of constant is always 0. P delta V is equal minus V delta P. So if you bring this one this side, delta P by minus delta V by V, how much? P. We call this as so bulk modulus is numerically equal to pressure of the gas. Bulk modulus is numerically equal to pressure of the gas. So now, when the scientist found the ratio between bulk modulus of a gas and its density, these are the two essential properties of a medium for the propagation of longitudinal wave. What is bulk modulus? Now you find that pressure only. Bulk modulus is about pressure. Pressure, force by area, force by density, mass by volume, mass by. Now what will cancel? L will go up. So what you got? B by rho is equal to L square T minus 2. Can I write this as L T minus 1 whole square? What is L square T minus 2? L T minus 1 whole. What is L T minus 1? Velocity. So this is velocity square. What is the velocity square? Ratio between bulk modulus and density of the medium will give square of the velocity. So what is velocity? That's it. What is the velocity of a longitudinal wave? B by rho U. The longitudinal wave is traveling through air or gaseous medium. But longitudinal wave can travel through solid, can travel through liquid, can travel through gas also. This is explanation of the gas. Longitudinal wave traveling through gas. Here I consider air as the gas. But this can travel through solid, through liquid, through gas also. So if longitudinal wave travels through solid, then how this formula will change? This formula for gases, then solids will have Young's modulus. Solids will have. So what is the velocity of sound in a solid? Root y by rho. Y by rho. In fluids, fluids, root b by rho. This can also be as root p by rho. Root. How we got this b is equal to p, students? How we wrote b is equal to p? I used this concept. PV is equal to nRT. T constant, right? N number of moles constant or universal gas constant. If T is constant, then PV is equal to K. P delta V plus V delta P is equal to 0. So from this P is equal to delta P by minus delta V by B, which is bulk modulus. How? When bulk modulus is equal to pressure of gas? Tell me condition. Condition. When temperature is on. So for isothermal process. What is this? Iso. According to Newton, who gave this formula? Newton. So here I am writing. According to Newton, the propagation of sound through air is isothermal. Propagation of sound wave through air is which process? Isothermal process. That's why he took T constant, he derived this one, he got this one, he wrote this one. So what is the velocity of sound in air? Root P by rho. Do you know these values? This is in air. Where? Velocity of sound in air. Do you know pressure of air? Normal temperature pressure. How much? Root over 1.013 into 10 power 5 by density of air 1.29 kg per meter cube. గాలి density how much? 1.29 kg per meter cube. Students, this is almost 1, this is 1 point, almost 3, 1.3 and under root 2. So Newton got speed of sound in air as 281 meter per second, and at that time some people believed, because Newton already has very good name and fame, so they thought that what is speed of sound in air? 281 meter per second. Then at the same time some other scientists, they have not used this formula, they measured distance traveled by sound and also time, distance per time, they got around 330 meter per second. This is the theoretical value. What is this? Theoretical value. And the practical value? V is 330 meter per second. If it is 329 or 331, 332, then almost both are equal. But there is a lot of difference between these two. Then this difference was pointed out by a scientist called Laplace. Laplace. Students, this is called Newton's formula for finding speed of light. What is this? Newton's formula for finding speed of sound in air. Now Laplace made a small correction. According to Laplace, propagation of sound wave through air is not isothermal. According to Laplace, propagation of sound in air is adiabatic. Which process? Not isothermal, adiabatic. Andre, according to Newton, temperature of the air remains constant. When a sound is traveling through air, temperature of air won't change, according to Newton. But Laplace proved that temperature slightly changes, not too much, but still temperature slightly changes. But when a sound wave is traveling through air, it won't receive any heat energy externally, and it won't give any heat energy to the surroundings. Neither absorb heat energy nor emit heat energy. So that's why it is called adiabatic process, where dq is equal to 0. Now what happens to this formula? According to Newton, PV is equal to constant. According to Laplace, PV power gamma is equal to, understood? PV power gamma is constant. So from this differential this one, what we get? P into gamma V power gamma minus 1 delta V plus V power gamma into delta P is equal to 0. Now this will become gamma P V power gamma by V delta V is equal minus V power gamma delta P. V power gamma cancel. So if you take this gamma P here, remaining terms delta P by minus delta V by V. What is this? According to Newton, bulk modulus is equal to pressure of the gas. According to Laplace, bulk modulus is equal to gamma times the pressure of gas. So what is the correction here? V, velocity of sound in air, is given by not P by rho. Actually this is B by rho. But B by rho will become, what is B? Gamma P. So V is equal to root B by rho, which is equal to root gamma P by rho. What is gamma for air? Diatonic 1.4. Pressure of the air 1.013 into 10 power 5. Density of air 1.29. And if you calculate this value, students, this value is root 1.4 times of this, 281 into root 1.4. So they got 331.2 meter per second, which is almost equal to this practical value. That's why which formula is correct here? Newton's formula or Laplace formula? Newton's formula is correct if sound wave is traveling through air at a constant temperature. But whenever wave is traveling, the temperature of the air is slightly changing. That's why we should not use this formula and we have to use only this formula. What is this? Newton's Laplace formula. What is the name of this formula? Newton's Laplace formula for finding Newton's Laplace formula. In some book, students, this is also called a Laplace correction. What is this? Speed of sound in a medium. Students, what is the Laplace formula or Laplace correction? V is equal to root over gamma p by rho. This is the expression to find out speed of sound in air. And if you observe this formula clearly, we can write as it is a Laplace correction, speed of sound in where? In air. So air is a gas, so we can write PV is equal to nRT. PV is equal to mass by gram water into RT. P is equal to M by V, RT by M. This is the density. P is equal to rho RT by M. So I need gamma P. Here I have P. Multiply with gamma on both sides, what we get? Gamma P is equal gamma rho RT by M. What is gamma P by rho? I am bringing this rho also here. Gamma now how this formula will change? V is equal to gamma P by rho. But gamma P by rho how much? Gamma RT by M. So can you say velocity of sound in air is given by root over gamma RT by M, which is correct? Both are correct. The same thing we derived. Gamma P by rho can also be written as gamma RT by M. So this is the expression to find out speed of sound in air. Speed of sound in air. Now from this what we can write, students? First equation, velocity of sound in air directly proportional to root gamma. If it is air, this is always 1.4. If it is some other gas other than air, let us say monoatomic gas, if your sound is traveling through hydrogen gas, hydrogen H2, you can write 1.4. If it is traveling through helium, then gamma changes. So speed of sound depends on atomicity of the gas. Atomicity means monoatomic, diatomic, triatomic, polyatomic. It is called atomicity. So what is the first condition? Speed of sound in air depends on, in gas depends on nature of gas. Nature. So what is the nature here? Monoatomic, diatomic or triatomic. Nature means mono, di or tri or poly. So it depends on gamma. Then V never depends on R. Why? R is a universal gas constant. And for a given gas, M is also constant. If you change the gas, V universally proportional to root M. If molecular weight is more, in that gas, speed of sound is less. Speed of sound is less. So V hydrogen, V helium. Otherwise, I will write helium, argon. In which gas speed of sound is more? In which gas? Both are monatomic only. Both are helium and argon monatomic. But helium is having molecular weight 4. Argon 36, 46. But now, as argon has more molecular weight, speed is less. Is it correct? Third one, V directly proportional to, if we change temperature, if we increase temperature, speed of sound also increases for a given gas. While writing these three students, V directly to root gamma if R, T, M are constants. V directly to root M if gamma, R, T are constant. V directly to root T if gamma, R, M are constants. If you see the formula, velocity of sound in a medium, generally gas is medium, V is equal to root over gamma RT by M. From this formula, for a given gas, what are constants here? Given gas. When a gas is given, through the gas sound is traveling. What are the constants here? Gamma, R and M. Gas is given, molecular mass constant, molecular weight, universal gas constant, gamma constant, all constants. Then for a given gas, how velocity depends on temperature? Directly proportional, under root. So V directly proportional to root T. V, always this is absolute temperature. So what we can write? Velocity of sound in a medium is directly proportional to square root of absolute temperature. Square root of, not temperature, square root of absolute temperature for a given gas. For a given gas. For a given gas. This is the statement. Statement and corresponding equation. When you are comparing this velocity of the sound in the same gas at two different temperatures, how this formula can be written? V1 by V2 is equal to root over T1 by T2, and this can also be written as T1 plus 273 by T2 plus 273. What is this T1? Temperature in Celsius scale, and further if you add 273 you get a Kelvin scale. So V1 by V2 is this much, root over T1 by T2 capital R, T1 plus 273 by T2 plus 273. Students, velocity of sound at T by velocity of sound at 0 degrees. This is velocity of sound in a gas at T degrees to the velocity of sound in the same gas at 0 degrees. How the formula will change? Tell me now. Root over T plus 273 by 0 plus 273. Artha is the same thing. So from this we can write V at T by V at 0 is equal T plus 273 by 273. So what is Vt? Vt is equal to V naught. This will come here. V naught root over 273 by 273 plus t by 273. Is it clear? ಅರ್ಥಾಗಿದಾ? Now velocity of sound at t degrees Celsius is equal to velocity of sound at 0 degrees into 1 plus t by 273 whole power 1 by 2. Root is nothing but whole power 1 by 2. This is in the form of 1 plus x whole power n. 1 plus x whole power n. So 1 plus x whole power n is 1 plus nx if x is much smaller than 1. So how you can write this one? Velocity of sound at t degrees Celsius is equal to velocity of sound at 0 degrees into 1 plus half into t by 273. So velocity of sound at t degrees Celsius is equal to velocity of sound at 0 degrees Celsius into 1 plus t by 546. 546. So this is the velocity of sound at t degrees Celsius. Velocity of sound at t degrees Celsius. T degrees Celsius. Now, if I want to find out the velocity of sound at 1 degree Celsius, wait, 1 degree Celsius. Same formula. Velocity at 1 degree Celsius is equal velocity at 0 degree Celsius into 1 plus what is t? 1 by. But what is velocity at 0 degrees? Generally it is given as 330 meter per second. How much? Plus 1 by 546. This will become 330 plus 330 by 546. Artha ida? 330 into 1 how much? 330. 330 into 1 by 546. 330 by 546. This will become 330 plus this value 0.61 meter per second. What is the meaning of this one? For every 1 degree centigrade rise in temperature, for every 1 degree centigrade rise in temperature, velocity of sound increases by how much? Increases by 0.61 meter per second. Andre here, see, velocity of sound at 0, 330 meter per second. What is velocity of sound at 1 degree? 330.61 meter per second. Velocity at 2 degrees. 330 add 61 to 12, 331.22 meter per second. Velocity at 3 degrees Celsius. Add 61, 331.83 meter per second. So what we have to remember? For every 1 degree rise in temperature, velocity of sound increases by 0.61. This is only for small values only. If temperature increases by 40 degrees, 50 degrees, don't multiply 40 into 0.61. Why? Because this is only for small temperature. This value should be very small. Suppose if it is 273 degrees, it is 273, 1 plus 1, 2. No. It will not double. It will not be doubled. Okay, this is only for small changes in temperature. You can use this value. For big changes, we will see now. The speed of sound in air, the formula, Newton's Laplace formula is root over gamma p by rho, which can also be written as, what is the other equation? Gamma r t by m. This is the other equation. In the students, Velocity of sound in air depends on gamma, depends on pressure, depends on density, depends on temperature, and depends on molecular weight of gas. So these are the factors affecting velocity of sound in air. So we will see one by one. What is the first one? First one, pressure of gas, because sound wave may travel through air or some other gas also. So pressure of the gas. Tell me, if pressure increases, what happens to velocity of sound in that gas? Repeat. No change. Pressure of gas has no effect on velocity of sound in that gas if temperature is kept constant. Temperature is kept constant. Students, from this equation we know PV is equal to nRT. P, mass by volume, is density, RT by M. So from this, what is P by rho? P by rho. If pressure increases, alright, we discussed this point in the starting of this class. Here pressure is more, density also more. Pressure is doubled, density will be doubled. Pressure is made 10 times, density made 10 times, because this ratio must be equal to RT by M. R constant to M constant per given gas. T, if temperature is kept constant, if temperature is kept constant, P by rho is variable or constant. So, if T is equal to constant, P by rho also constant. If pressure is doubled, tell me, pressure is doubled, what is the meaning of this one? Density also doubled, P by rho constant. That's it. For a given gas, gamma already constant. For a given gas, gamma always constant. For a given gas, at a constant temperature, P by rho also constant. So now read this statement. Factors affecting speed of sound. Pressure of gas in air or in a gas. Pressure has no effect on velocity of sound if temperature is kept constant. If temperature changes, then that will change, but I am talking about pressure. Number 2, molecular weight of gas, whether it is showing some effect or not. See this one, V, if gamma or T are constants. Okay, even if temperature is constant, M, for two different gases, M is different. So what we can write? Velocity of sound is more, velocity of sound is more in heavier gases or lighter gases? More in lighter gases and less in heavier gases. Clear? This is a second effect. Third one, temperature. Already we studied there. What is the effect of temperature? V. If temperature increases, velocity not directly proportional, directly proportional to root T. And there is a double agala. If it is doubled, this velocity will become root 2V. V1 by V2 is equal to root over T1 by T2. If temperature is doubled, what is V2? Root 2 V1. V2 is root 2 V1. If temperature is doubled, velocity will not become doubled. Velocity of sound will become root 2 times. Fourth one, humidity of air. or that gas. Students, when it rains, just after rain, if you speak in that atmosphere, sound travels with greater speed. Have you observed this one? Just after rain, because before rain or after rain, the air will become humid. What is meant by humidity? The percentage of water molecules present in air. What is humidity? Water content in air. Water content in air. If you say this, gamma is the pressure also constant. If you take only this one, root rho. This is dry air. What is this? Dry air. This is dry air. This is wet air. Same volume. Here we have only air molecules. Here we have air plus water. What we have here? Only air molecules. Here air plus, when the water comes here, what happens? When the water comes here, it will move the air particles present. Some of the air particles will move away. So previously, how many air molecules are there in the diagram? Let us say 20. Now air molecules are 15. Same one. Why 15? Remaining 5 molecules, air molecule space is occupied by water. Then, what is density here? Density. Mass of 20 air molecules by volume. What is density here? Then 15 molecules by volume. Which is more? Dry air has more density. Dry air has. So rho dry air greater than rho wet air. Now V, you know the root V now? V. Now tell me, pressure is not changing. Pressure is not changing, only density changing. So for wet air, density is less, velocity is. So what we can write statement? Velocity of sound in wet air greater than dry air. Correct. What is the conclusion? Velocity of sound in wet air is more than in dry air.